Hi, so in today's video what we'll be doing is we are covering prime factor decomposition. Make sure to like, comment, share and subscribe so others can benefit as well. So before we can do prime factor decomposition, we first need to know what prime numbers are. A prime number is a number which is only divisible by 1 and itself. So it would only have two factors. If you watched one of the previous videos, I went over what factors are. You can always refer back to that for extra help. So for example, if we have the number 7, 7 is only divisible by two numbers. It's divisible by 1 and itself. So 7 fulfills this condition. So 7 is a prime number. If you can put any other prime number in this section here and it's only divisible by 1 and itself, then that will be a prime number. 1 is not a prime number as it has only one factor. Remember what we said before, it will have two factors, 1 and itself. The number 1 has only one factor, which is itself. These are the first few prime numbers which are all under 30, and what you should recognize is that the only even prime number is 2. So 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29 are all the prime numbers under 30. So now that we know what prime numbers are, let's go through prime factors. So prime factors are factors of a number that are also prime numbers. So let's look at the number 30. The factors of 30 are 1, 2, 3, 5, 6, 10, 15 and 30. So these are all the factors of 30. The numbers 2, 3 and 5, these are all prime numbers, and we will say that these are the prime factors of the number 30. Let's go through prime factor decomposition. So when we write a number as a product, and the word product means multiplication or multiply in terms of math. So when we write a number as a product of prime factors, it is called the prime factor decomposition. So let's look at a few examples. The number 30, we can break down into 2 times 3 times 5. Yes, these are all prime numbers. If you multiply them together, you will get the number 30. So 2 times 3 is 6, 6 times 5 is equal to 30. The same for 77. 77 can be written as 7 times 11. 7 is a prime number, 11 is a prime number. So this is a product of its prime factors. Let's look at the number 100. 100 is 2 times 2 times 5 times 5. 2 is a prime number, 5 is a prime number. What generally will happen is you would write this in index notation. Again, index notation we covered in one of our previous videos. So 2 times 2, it was written as 2 squared, and 5 times 5 will be written as 5 squared. So we can say that every positive whole number can be written as a product of 2 or more prime numbers. There are some further conditions, but for now, this statement is sufficient. Now the method that we're going to use to work out prime factor decomposition is something called a factor tree. So the way you would do this is you write the number. So we're looking at the number 77. You think of two numbers which multiply to give to 77. In this example, you can write 7 and 11. Is the number 7 a prime number? Yes, it is. So we can put a circle around it. And is 11 a prime number? Yes, it is. So we can put a circle around it. So 77 written in prime factor decomposition is 7 times 11. Here is another example for us to go through. Let's look at the number 24. So think of two numbers which multiply to give to 24. We know that this is 2 times 12. So you will draw two arrows coming from 24. Is 2 a prime number? Yes, it is. So we'll put a circle around it. Is 12 a prime number? No, it is not. So we're going to break this down even further. What two numbers multiply to give to 12? You know that this is equal to 2 times 6. Again, you draw two lines coming from the number 12 and you circle numbers which are prime numbers. Is 2 a prime number? Yes, it is. We'll put a circle around it. Is 6 a prime number? No, it is not. So we have to break this down even further. Which two numbers multiply to give to 6? We know that this is 2 times 3. Is 2 a prime number? Yes, it is. Is 3 a prime number? Yes, it is. Because we can't draw any more arrows and each of these final numbers have circles around them, this will be the answer. So we will say that 24 is equal to 2 times 2 times 2 times 3. So all of the numbers you have put circles around, those are the numbers which are the prime factor decomposition of the number 24. 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is obviously 24. Again, generally you would write this in index notation. So 2 times 2 times 2 can also be written as 2 to the power of 3 times 3. A common question is, are there any specific numbers which you should always choose at the start? So let's pick two different numbers. So we're going to pick 8 and 3. Is 8 a prime number? No, it is not. Is 3 a prime number? Yes, it is. So we'll put a circle around 3 and let's break this 8 down even more. 8 can also be written as 2 times 4. Is 2 a prime number? Yes, it is. Is 4 a prime number? No, it is not. Again, we'll break down 4 into 2 times 2. 2 is a prime number. This 2 is a prime number. And again, you're left with 2 times 2 times 2 times 3. So 24 is equal to 2 cubed times 3. So in my opinion, this left way is much neater in writing it down. You'll have all the prime numbers on the left until you get to the bottom numbers. You can do it in the second example. It's totally up to you as long as the answer at the end is correct. Here are 3 different questions for you to attempt. You can pause the video and have a go, and we will go through the answers on the next slide. Hopefully you had a chance to attempt the question. Let's go through some of them. So write 35 as a product of its prime factors. 35 we know is equal to 5 times 7. Is 5 a prime number? Yes it is. You put a circle around it. Is 7 a prime number? Yes it is. You put a circle around it. 35 is equal to 5 times 7. So the first one was fairly simple. Let's look at the next number, 36. 36 is equal to 2 times 18. Is 2 a prime number? Yes it is. Is 18 a prime number? No it is not. So we're going to break this down even further. 18 is 3 times 6. Is 3 a prime number? Yes it is. Is 6 a prime number? No it is not. So we're going to write this 6 as 2 times 3. 2 is a prime number, 3 is a prime number. You'll collect all of the 2's. So there's 2 2's, so it's 2 squared multiplied by 3 squared. You know that 2 squared is equal to 4, 3 squared is equal to 9. 4 times 9 is equal to 36. So it's always good to check your answer at the end to make sure you get back to the original number. Let's go through the final question. 48 we know is 2 times 24. 2 is a prime number, 24 is not. So we're going to break down 24 even more. 24 is equal to 2 times 12. 2 is a prime number, 12 is not. We're going to break down 12 even further. 12 is equal to 2 times 6. 2 is a prime number, 6 is not. We're going to break down 6 even further. 6 equals 2 times 3. You collect all the 2's. So there's 1, 2, 3, 4. 4 2, so it's 2 to the power of 4 multiplied by 3. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 3 is 48, which was our original number. Here is a summary page of what we have gone through today. So we have gone through what prime numbers are, we have gone through what prime factors are, we have gone through what prime factor decomposition is, and we used a method to find the prime factor decomposition of a number by using something known as a factor tree. I hope you have been able to benefit from today's video. Hopefully I'll see everyone safe and sound for the next one. And as always, take care of yourselves.